In this lesson, we're going to cover the use of BGP AS Path Access Lists. AS Path Access Lists are much like standard ACLs in that they leverage permit and deny statements. The biggest difference from the run-of-the-mill ACLs is that AS Path Access Lists use regular expressions to match on the desired AS Path information. There are several regular expressions that we can leverage within the AS Path Access List. Here I have displayed a couple of examples of those regular expressions, where we have caret for start of string, $ for end of string, and many others. So if we were to use a dot star will match on any, a caret with the $ means locally originated routes, a caret with an AS number followed by an underscore means routes learned from that AS. An underscore and then an AS number matches on routes originated from an AS. And an underscore, an AS number followed by another underscore is an occurrence of that AS in the AS path. Let's configure a couple AS path access lists and associate them with our BGP neighbors. Here on Leaf 4 in the lab, we'll enter configuration mode by typing config, enter, and then IP AS-path access-list, and a question mark here will show us that we need to name it. We'll call this one AS path test 1. And then another question mark shows us this is where we insert either a deny or a permit. So I'm going to put in a deny, and then I'm going to use an underscore and then 65101 so that we match on any routes originated from AS 65101. I'm going to follow up with an IP AS-path access-list AS path test 1 permit period and star to permit anything else. Let's write another one. IP AS-path access-list AS path test 2 deny, and in this one let's do an underscore 65102 to match on any routes originated from AS 65102, and then our permit IP AS path access-list AS path test 2 permit period star. We can verify those with the show IP AS-path access-list command. And there in the output, you can see our 4 lines for the 2 separate AS path access lists. Let's apply the first one to both of our BGP neighbors. We can see that the BGP neighbors of this switch are show IP BGP sum 172.16.200.13 and 200.29. And here on the right, we can see how many routes we're receiving from each of those BGP neighbors. We can give more details about those routes we're receiving with commands like show IP BGP neighbor 172.16.200.13 and the keyword received -routes. And we see all kinds of information about the prefixes, their next hop, any metrics or local preferences, weights, and then to the far right there, our AS path. And we can also issue that command for our 200.29 neighbor and see similar output. The route 172.16.0.3 comes from AS65101. It's actually the loopback of Leaf 1. Let's verify that we know that route before we make any changes. Show IP route 172.16.0.3, enter. And we see we're running that route via external BGP with the current next hop of 200.13. To apply this AS path to our neighbors, we're going to write a route map. That route map is going to call the AS path list, and then we're going to assign that route map in our router BGP configuration. So to create the route map, the command is route-map, and we'll call this AS path testing. And then a question mark shows here we need either a permit or deny. We're going to do a permit. And then another question mark shows us a sequence number, or what some folks call a stanza. So I'm just going to number this 10. Then the next line is a match statement. So we can do match space question mark and see all the options that we have for matches within this route map. In this example, we're going to match with the keyword AS-path, and then a question mark shows we need to reference the AS path access list name. Here we'll do AS path test 1 and then enter. If we exit the route map configuration, we can verify it with the show route-map command, and we see our AS path testing route map, one stanza, it's a permit, and we're matching on ASPath with the name ASPath test1. Now we're going to get into router configuration mode and reference that route map on our BGP neighbor statements. Router BGP 65104, enter, and then neighbor 172.16.200.13 route dash map AS path testing, and then we need a direction, either inbound or outbound. In this case, we're going to do inbound. And then we're going to repeat that for our other BGP neighbor, the .29. Neighbor 172.16.200.29 route dash map AS path testing, and then also the direction of in. We can verify our BGP configuration with a show run section router BGP command. And in the output there, you can see our route map reference on both the 200.13 as well as on the 200.29. If we check our BGP neighbors, let's exit out of router configuration mode and type show IP BGP sum. You can see that our neighbors are still established. We've been up for over 3 hours. We still have the same amount of prefixes received, but the ones we're actually activating from our RIB to our FIB has declined significantly from 16 and 17 down to 11. If we issue the command show IP BGP neighbor 172.16.200.13 with the keyword received routes again, we'll see all of our routes are still in the RIB. And we'll do that on .29 as well, the other BGP neighbor. And we can see we still have all those routes in the RIB. But the show IP route 172.16.0.3 shows us that now we're no longer learning that route via external BGP. We filtered out everything coming from the AS 65101. Let's reconfigure our route map to match our other ASPath access list. That ASPath ACL is going to block routes from AS 65102. And the route that we're currently learning from there is 172.16.0.4. So let's make sure we have that in our routing table. Show IP route 172.16.0.4, enter. And we can see, yes, we're learning that route via external BGP with a current next hop of 200.13. Let's go in and edit our route map, route-map ASPath testing, our permit 10 statement. And here we'll do a no match AS-path ASPath test 1, enter. And in its place, we're going to put in ASPath 2. Let's exit out of this and make sure it's gone. Show route-map. And we see indeed we still have our route map with our permit 10 statement, but currently no match clauses. So get back into that configuration, route-map AS-path testing, permit 10, and match AS-path. And this time we'll match on the second AS-path list we created, AS-path test 2. Exit out of the route map configuration, verify our route map, show route-map, shows us we now have a new match clause, AS-path, AS-path test 2. Show run section router BGP shows that we still have that route map applied to the 200.13 neighbor as well as the 200.29 neighbor. Let's check on that route and see if it's gone now. Show IP route 172.16.0.4, enter. And you can see now that that route is gone. We no longer have it in our routing table from BGP. Finally, let's remove the route map from our BGP neighbor statements and ensure that we get back both the 172.16.0.3 and the 172.16.0.4. Show run section router BGP, enter, and then in config mode router BGP 65104, enter. The no keyword, and then I'm going to save time here by copying this in. No for the 200.13 route map reference, and the same on the 200.29 route map reference. We'll put a no and then cancel out that neighbor route map command. Exit out of router BGP configuration mode, reissue the show run section router BGP command, and verify that we're no longer referencing a route map. Let's check our BGP neighbors, show IP BGP sum, and see that we still have our neighbors, they're still established, And we're now actively receiving more routes than we were before. And then finally, the two routes we were playing with, show IP route 172.16.0.3, enter. And we see we're learning that again via BGP. And then also show IP route 172.16.0.4, enter. And we see we're also learning that route again via our external BGP. There are several ways we can filter routes in BGP. Some examples include not only these AS path access lists, but also prefix lists, and we can leverage communities. Choosing which of the options often depends upon your existing deployments and configurations. It's nice to know that there's always more than one way to do it.